Good morning, my YouTube viewers. It is Crystal here, and I'm doing another code review for you in R. And what we're going to do in R is we're going to do an ARIMA forecast on R's inbuilt Johnson & Johnson dataset. So basically, I found out recently on Stack Overflow really that you can program R in Google Colab, which primarily is designed for Python, but you can program it in R if you type the language equals R along with the code for Google Colab into the browser. And so that's made it easier for me to program in R. And the reason why is because in R, mainly, there's just online compilers that you use. And because there's online compilers that you use, it's not really suitable for me. So it's really great that I'm able to use Google Colab to program in R. And I think you might think it's really great as well. And in my other computer, my Chromebook computer, I've got an R compiler, a free R compiler from Google Store, but it still doesn't work, in my opinion, as well as Google Colab. So I think Google Colab is the software package that I like to use the most for programming. So we're going to use R's inbuilt Johnson & Johnson dataset, and we're going to do an ARIMA forecast on that. So Johnson & Johnson dataset is the company's earnings per share in US dollars from 1960 to 1980. So basically we have to call up the Johnson & Johnson dataset by typing data brackets Johnson Johnson. And then we check the class of this dataset by typing class brackets Johnson & Johnson and find out that it's a time series. And don't forget, in order to get Google Colab to work in R, you have to type in this code right here in the remarks to get you in the language equals R. We check the structure of Johnson & Johnson, and you can see that it's time series with 84 entries from 1960 to 1981. And basically it's blocked out into 12 years, I think it is. It's 20 years. 20 years and 12 months. So our start is 1960 and the first cell, and the stop is 1980 and the fourth cell. So I got that wrong. It's not 12 months, it's 4 quarters. So it's 20 years and 4 quarters. So 20 times 4, or really 21 times 4, is 84. So the length of the Johnson & Johnson dataset is 84. So we're going to view the Johnson & Johnson dataset, and you can see that it is an inbuilt data frame of 1960 to 1980 and 4 quarters. Now what we're going to do is we're going to create a scatter plot of the Johnson & Johnson earnings per share. And so I will you can pause the program, pause the video, and type in this code here to plot a scatter plot. And then we're also going to add a trend line. And so model becomes LM, that's linear model, Johnson & Johnson tilde time Johnson & Johnson. And then you put a red line, an AB line, brackets model, comma, color equals red, LWD is line width equals 2. And then we put a grid in it. So this is what Johnson & Johnson's earnings per share look like in a scatter plot. And you can see here that the EPS, earnings per share, increases annually. And it's sort of like a polynomial, figure that it creates, because it's not strictly linear, but you can see with the linear line and the scatter plot across the linear line, you can see that it's nonlinear. It's more like a polynomial. So we also create a line plot of the Johnson & Johnson data set. Then when we create the line plot, you can get a clearer look at it. And you can see that every year the earnings per share increase. So now what we're going to do is we're going to do the ARIMA model. And in order to do the ARIMA model, we're going to have to calculate the PDQ. And the ARIMA model is a time series forecasting model, with ARIMA is autoregressive, or AR is autoregressive, I is differencing, and MA is the moving average. So in this model, it employs autoregressive, differencing, and moving average. And so your P is your autoregressive, your D is your differencing, and your Q is your moving average. So first thing we're going to do in order to complete the ARIMA model is we're going to set up our training set and our test set. So your training set is going to be 60 elements, and your test set is going to be 24 elements. So your train becomes window brackets Johnson & Johnson start equals C. And C is the way that you put a series of elements together. C brackets 1960, 1, N, C equals 1974, 4. And then the last four values, it's the same as its test X becomes window brackets Johnson & Johnson's start equals C 1975, 1, N, C 1980, 4. So that's the difference between Python and R. So if you want to declare a list of elements, you have to put C in there before you declare the list, but you don't have to do that in Python. I will say Python is a very forgiving language, but the thing is that R is a language that is designed just for statistics, whereas Python is a general purpose language. So R has a lot of functions built into it, whereas Python does not. If you want to do something specific with Python, you have to use a library, whereas you don't necessarily have to do that for R. R does have libraries, but it also has inbuilt functions. And so I'm trying to use just the inbuilt functions in R, because I tried to install a library using R, and it took a really long time to do it. And I thought, well, I don't have time for this, so I didn't want to do it. So now what we're going to do is we're going to set up our PDQ. Your P value is 0 to 8, your D value is 0 to 3, and your Q value is 0 to 8. We're going to set up our best score, which is infinite, and our best configuration, which is null. And then we're going to set up a series of for loops for P and P values, for D and D values, for Q and Q values, and then order becomes C, P, D, Q. And try catch is like try except in Python. So we're going to fit the ARIMA model on the training side, training data, fit becomes ARIMA brackets train X order equals order. And then we're going to forecast the length of the test set. So in head becomes length test X. Pred, that's your prediction, becomes predict fit, comma, in dot head equals in ahead. And then we're going to calculate the error. That's RMSE, root mean squared error, becomes square root of mean brackets test X minus pred squared. So that's your RMSE. And then you're going to track the best model. If RMSE is less than best score becomes RMSE, best configure becomes order. And then CAT, and that means CAT is similar to print, brackets sprintf, ARIMA, and then it's going to be PDQ, RMSE is going to be RMSE. And then you're going to have error equals function E, and it says skip failed fits. And then at the very end of it, you're going to print the best ARIMA, that's PDQ, and the RMSE. So basically, you're selecting the best ARIMA on the lowest error. So you can see that as we run through this program, we've got our ARIMAs. Your ARIMA starts out as error of 8.95, and it goes all the way down to 0.36 of 1.927. And it keeps going all the way through, giving you these error messages. Goes all the way through it. It's 537, and then and the very last one was 537 with the RMSE of 1.730. But and then what you have to do is you have to manually put in the order into the new ARIMA model. And basically what I did was the 537, it went into error. And so what I did was I found an order that didn't go into error, and I used that because it prints all the orders for you as well. So ideally, ARIMA 537 would work, but it went into error at 537. But it didn't go into error at 036, so I used 036 on the ARIMA model. And then I fit it, and then when you fit it, you get your call and your coefficients and your sigma squared estimated at 0.4888, a log likelihood at -97.47, and an AIC at 208.95. And AIC is an indicator. It is a goodness of fit indicator. So now we're going to do some diagnostic plots, TSDIG fit, and then we're going to make predictions on pred, and we're going to predict ahead for 10 years or 10 cells. And then we're going to print the pred. We're going to print the predictions. And so you see we've got the predictions printed up in the bottom. And then we're going to plot the forecast. So we're going to plot it as Johnson & Johnson and then the predictions. And the color is going to be black and blue. And LTY equals C1, 2. And then we're going to put a line in red, which is going to be the error, 2 lines in red. So one is going to be the prediction plus the error, and then prediction minus the error. So it could go anywhere between the errors as well. So when we plot it, it gives you the standardized residuals. So there's your residuals. Gives you your ACF residuals. It gives you your p-values for L-Jung box statistic. And then it gives us the chart. And so this is the blue is the prediction, and the two reds, or the prediction, can go between the blue and the red. So that's what came out with this ARIMA chart. So some people are saying to use as the order 100, but you know, if you use 100, because like whenever you're working with a data set that you've never used before, you're going to have to figure out a way to select the order. And there is a way that you can like manually look at these charts, and these charts will tell you how to calculate the order, but I haven't figured out how to manually look at the charts. I would need to have somebody show me how to do it. So I prefer to do it with the formula in code. So that's it. That concludes this video. We've done the ARIMA, and I've explained the ARIMA code to you. If I ever figure out how to manually look at the charts and find the order, I will. But basically what you're supposed to do is you're supposed to print off all these charts and decide what the order is based on the charts. But I personally prefer to use a computer program to do that rather than to eyeball it. So that concludes this video. If you like my video, please like and subscribe. I will be making some more R content for you soon. And thank you again for watching my video, and I'll be communicating with you soon.